Hi, Chad. I find this easier just to do 5 or 6 minutes of a quick video on those questions on the questions that you had over the quiz here. Um, so here, here's the information we've got. I thought I did it here in this one, but I guess I just finished with the velocity of the glove. Okay, but anyway, so the next set of problems. All right, so a hockey puck. All right. Um, hockey puck has a mass of it, and I'll show you my work here in a second. M1 is equal to 0.175 kilograms, and the glove M2 is equal to 0.85 kilograms. It's a pretty heavy glove, all right? And the initial velocity, the puck is 45 meters per second. And again, I'll let you see all this in a second. And the initial velocity of the glove is equal to 0. All right, so here we go. We're going to assume, and then I'll get into answering the question. So I think the first thing we wanted to do was we wanted to find the final velocity of the glove, okay, after the collision. We're assuming that there was a collision and the hockey puck was going back the other way, and the glove, of course, was recoiling. So the hockey puck's going to go, so here's, oh, the way I've drawn it. All right, so that might be part of what's confusing. All right, so here's my hockey glove, the best I can. Looks like a lobster claw. All right, it's stationary here. The hockey puck is coming in here. Actually, yeah, the hockey puck is coming in here at minus 45 meters per second. So the hockey puck is coming in here, and then boom, they have a collision. The glove recoils back this way with a final velocity of 2, or V2 final, and the hockey puck is going to recoil back this way with a V1 final, V1 final speed. Okay? All right. So here we go. Here we go. Yeah. So we know this. We know that the momentum's conserved. So the momentum before is equal to the momentum after. All right, momentum before is equal to the momentum after. Now the momentum before is M1 times V1 initial plus M2 times V2 initial, which, okay, after the collision, that's going to equal M1 plus V1 initial. Aha. Oh, the puck recoils in a positive rate of 15 meters. But I was going to say that's going to be tricky if I don't know. Is equal to M1 V1 final plus M2 V2 final. All right. If I hadn't given you that the recoil of the puck, the final thing of the puck was positive 15 meters per second, this would have been a very difficult. We couldn't have solved it. Well, we could have using kinetic energy things, combining stuff and all that, and it would have been just very, very difficult. All right, but anyway, so we at least got it. We at least have what we need. Okay, so let's just do it algebraically to get started. So what are we after? We are after, what did they ask for here? Calculate the recoil of the hockey. So we want to find V2 final. That's the first thing we want to find. Okay, we want to find V2 final. I bet you it's going to be negative too. So the glove is stationary when we start. So we've got M1 V1 initial plus 0 is equal to M1 V1 final plus M2 V2 final. Okay, so let's just do the algebra here. So we've got M1 V1 initial minus M1 V1 final divided by M2 is equal to V2 final. Okay, now I'll be upfront with you. This would have been a problem on maybe even a Physics 240 exam, okay, for engineers. All right, so it was a tricky problem. Now, all we got to do is plug in the numbers, 0.175 times minus 45 minus, now notice the velocity of the puck, the final velocity of the puck was 15 positive. So it was positive over here, we bring it over here, now it's minus. 0.175 times 15, I've already factored out the negative sign, divided by the 0.85, and that should give me the final velocity of the hockey puck. Okay, well, let's just plug it in. All right, we're going to do a little factoring here and do it this way. Say, all right, we've got 0.1. Oh, I already got a negative sign in there. I got to clear all that. 0.175 times minus 45 minus 15. So what we have here, that's my top. That's negative 10.5. Okay, divided by 0.85. Negative 12.35. Okay, which makes sense to me. Negative, because that 45 meters per second, that's we're getting close to 100 miles an hour there. All right, it's coming in at 100 miles an hour, bang, that hits that glove, and the glove recoils. And also there's the other thing too is the glove is just laying there on the ice. Okay, there's not a body stopping it. That is not, that takes away, then the system is not, the momentum in the system has changed because we've added more stuff to the system. And just our glove puck system, so this glove was just laying on the ice and got hit. That might have been what was confusing. Okay, so that's the recoil of the hockey glove. Now, what else did we need to do? Oh, this was the kinetic energy. Okay, calculate the kinetic energy of the glove and puck system before the collision. Okay, so we'll calculate the kinetic energy before the collision, and we'll connect the kinetic energy after the collision. All right, so what that means is, and you can plug in the numbers because I'm going to cut this short. Because I should probably make this two. As a matter of fact, I'll make this two movies.